All right, so today what we're going to do is we're going to talk about long division with polynomials. Okay? Now, before we dive into that, we need to review long division with good old-fashioned regular numbers. Okay? So we're going to remember from back in the day how we divide using long division. We're going to practice with 279 divided by 2. Okay? You would either see it written with this division sign right here or with the fraction bar, 279 over 2. So, if you'll remember, when we write this, we put the 2 on the outside, and then inside we put the 279. Okay? Now let's try and remember our steps for long division. Okay? What do we do first? Good. We divide. We do 2 divided by 2, and how many do we get? 1. So our first step is to divide. Then what do? Multiply. What do we multiply? 1 times 2, and I get 2. Then what do? Subtract. I get 0. Then what do? Bring down. So I bring my 7 down. All right? So now I'm doing my 7. How many times does 2 go into 7? 3. 3 times 2 is 6 minus 1, or minus 6 gives me 1. Then I bring down. So I keep repeating this pattern, right? Divide, multiply, subtract, bring down. Divide, multiply, subtract, bring down. Okay? 2 goes into 19. 9 times. Get 18. Subtract and we get 1. Now at some point when you were learning how to do this, you put a decimal point and a 0 and you kept going, right? To get the decimal version. Okay? That's great, but we're not going to do it that way. Okay? When you very, very first learned long division, what did you call this number? The remainder. Okay? When you very first learned it, you might have written something like 139, remainder 1. Right? Okay? We want to concentrate on the idea of remainder. Okay? What was the next way you learned how to write it? Maybe something with a fraction or a mixed number. 139 plus 1 over 2. Okay? Remember that way? That was the other way we wrote it. We wrote our whole number answer, and then we took our remainder and we put it over whatever we were dividing by. So,
I mean, does it matter for this thing if we just add the 0, at the very end, and then divide?
No, you need to be practicing this way. We're not doing decimals. All right? Questions? Do we remember this? Yeah? You feel okay? Okay. Remember, when you first did long division, was it easy? The very first time you did it? The very first time you did it, it was not easy, right? Okay? The very first time we do this, it's not going to be easy. But you're going to get it. Okay? You just have to follow the steps with me. So, we are going to practice dividing polynomials. Okay? For real. All right? Why in the world would I put you through this? Why would I make you divide polynomials? Okay? We have to divide polynomials in order to find roots and to factor. All right, so we're going to start off the same way again. This is what I'm dividing by, x squared plus 2x minus 3. Inside goes my polynomial that I am dividing into. Okay, now remember those same steps. We're dividing, then we're going to multiply, we're going to subtract, and we're going to bring down. Okay, right now I'm only paying attention to the first term, x squared. I'm dividing x squared into 2x to the fourth. So I'm saying 2x to the fourth divided by x squared. The other way you can think of that is you can say x squared times what gives me 2x to the fourth? 2x squared. That was our division step. Now we are going to multiply. We're going to take 2x squared and we're going to multiply it by this whole thing. 2x squared times x squared. 2x to the fourth. 2x squared times 2x. 2x squared times negative 3. Divide, multiply, then what? Subtract. So, to subtract, I'm going to go through and I have to subtract each one of these. So I'm going to change each of their signs. Okay? I'm going to make this a negative 2x plus 4. I'm going to make this minus 4x to the third. I'm going to make this plus 6x squared. Because when I subtract, I'm basically subtracting this whole thing in parentheses. So I'm basically going ahead and distributing my negative now so that I can just go through and add. It's for the subtract step. Okay? All right, 2x to the fourth plus negative 2x to the fourth. What happens? They cancel. This must happen every single time. Your very first term must cancel. Does it always happen when you use numbers? No. When we do it with polynomials, it must cancel. Okay? Now, what happens on the next one? Those also cancel. Those do not always have to cancel. That's just a nice thing here. Okay? How about negative 5x squared plus 6x squared? It's x squared. All right. How many did I cancel? 2 terms, so that means I get to bring 2 terms down.
So the number of terms are canceled, the number of terms are all.
Correct. So we just went through one cycle, okay? So now we start the cycle over again, and we start with dividing. What times x squared gives me x squared? 1. So I'm going to put plus 1 up here. After I divide, I multiply. 1 times x squared is x squared. 1 times 2x is 2x. 1 times negative 3, negative 1. Sorry, negative 3. So after we multiply, we subtract. So again, to subtract it, I'm going to go through and I'm going to change all the signs. Minus, minus, plus. X squared minus x squared cancels. 2x minus 2x cancels. Negative 3 plus 3 cancels. So I'm left with 0. So what is my answer to this division problem?
2x squared plus 1.
Yep. 2x squared plus 1 is, in fact, my answer. What do I call this 0? My remainder. The 0 is my remainder. 0 as a remainder is something that is very nice. When 0 is our remainder, we get a very important piece of information. And what that information is that x squared plus 2x minus 3 is a factor of this big polynomial that we started out with. Okay? It tells me that what I was dividing by, x squared plus 2x minus 3, is a factor. And remember I told you the reason we're learning this is to factor things we weren't previously able to factor. Okay? Well, now we are able to factor them if we know some information.
I don't understand what you mean by it's a factor.
Okay? Remember if we had something simple like x squared plus 2x plus 1 or whatever, and we would factor it, and we would come up with two things in parentheses. This is going to be one of those factors. When those things that were in parentheses, those are our factors. So this is one of the factors of this whole thing. What's the other factor? Right, 2x squared plus 1, because if I multiplied these together, I would get back to my original polynomial. Okay? So, now we can factor and find roots of this polynomial. Okay? So, this is what we started out with. That was what we just did our division on. And what was the answer that we got? 2x squared plus 1. So that's one of my factors. And what was my other answer? X squared plus 2x minus 3. Is this factored completely now? Why not? Yeah, x squared plus 2x minus 3 factors. Back with those plain Jane original rules of factoring. Okay? So would you take a minute, please, and would you factor x squared plus 2x minus 3? If you need to do it off to the side, that's totally okay. All right, so what does that factor into? Yep, x plus 3, x minus 1, and this, can that be factored at all? No. Nope. So this is the most factored form of the polynomial that we started with, that quartic polynomial that we started with. Okay? Let's think about what else we can figure out here. After we factor something, we're also able to find their roots. How do I find roots from here? What do I do with each of these factors? Yeah, so I'm going to set them equal to 0. 2x squared plus 1 equals 0. Subtract 1 from both sides. 2x squared equals negative 1. X squared equals negative 1/2. What do I do to both sides there? Square root. When I square root, if I add in the square root on my own, what else do I have to add in? Plus or minus. Good. So this is x equals plus or minus the square root of negative 1/2. What happens now? There's an I, good. X equals plus or minus the square root of 1/2 I. Now, if you got all the way here, you basically got 99%. Okay? But what else could be done to this? You separate it, and then you have to rationalize the denominator, right? So you multiply the top by root 2, the bottom by root 2, and this is going to simplify to plus or minus root 2 over 2, okay? That's just when we rationalize, we do root 2 times over root 2, okay? If you don't remember that, it's okay. We can practice it another time. That's not the big idea here, okay? Big idea is here's 2 of my roots. What's my root from x plus 3? And x equals 1. So my roots are plus or minus root 2 over 2I, negative 3, and 1. How many roots are there? 4. Why are there 4? Good. Plus or minus means I've got 2 roots here. So I have 4 roots total. How many are real? 2 real. And how many are imaginary? 2 are imaginary. So how many x-intercepts do I have? 2. An imaginary root does not cross the x-axis. Only a real root crosses the x-axis. Now if you look up here, x to the 4th, when you see a 4th power, that's how many roots you should come up with. But do they all have to be real? Nope, they don't all have to be real at all. Okay? All right, let's give this another try. X to the... No. Because we did a lot more. We just talked about the big picture stuff. Your homework is mainly going to be practicing long division. All right. X to the 4th minus 10x squared plus 2x plus 3 divided by x minus 3. Now, don't get too far ahead of me writing out this division problem. Okay? So, we are going to write our x minus 3 on the outside. All right. We go from x to the 4th, and then we skip down to x squared, x, and then our constant. What place value, if you want to kind of call it that, is missing? X cubed, okay? When you do long division, every place, kind of place, you know what I mean, when like tens, hundreds, thousands? If you want to think about places with all the exponent powers, all the variables exponents, they must all be represented, okay? So here I've got x to the 4th. I don't have an x cubed, but I must represent it. So I could say plus 0x cubed. Then I've got minus 10x squared plus 2x plus 3. If you leave out that step, your whole answer is off. Okay? You have to check that each place is represented when you do long division. Okay? All right. So let's start our process. What times x gives me x to the 4th? X cubed. Here's how you check if you put the right number there. X cubed times x, does that give me x to the 4th? Yes. These two numbers must be exactly the same. If you didn't get those two numbers the same, something went wrong. Okay? Keep multiplying. X cubed times negative 3. Okay? Now we subtract, so change your signs. Negative x to the 4th, this becomes positive 3x squared. X to the 4th minus x to the 4th, 0. If that doesn't cancel, gotta try again. 0x cubed plus 3x cubed. How many did I cancel? 1, so how many do I get to bring down? Just 1. All right, so there's our cycle. Now we keep going. What times x gives me 3x cubed? 3x squared. 3x squared times x gives me 3x cubed. 3x squared times negative 3 gives me negative 9x squared. And then what do I do to all my signs? Flip your signs. Minus, plus. Do my first terms cancel? They better. They do. Negative 10x squared plus 9x squared. Negative x squared. What times x gives me negative x squared? Negative x. Oops, change colors. All right, I want you to keep going. Try and finish this one out. Just wait. You shouldn't have gotten there. I'm going to finish working it out up here. So if you want to check your work. So your answer should have been x cubed plus 3x squared minus x minus 1. What is my remainder? 0. What does that mean? What's a factor? Yeah, x minus 3 is a factor. Any questions on any of those steps? What's your answer to this question, though? Yeah, this up here, x cubed plus 3x squared minus x minus 1. It's not that x minus 3 is a factor. That's just information we have gained. Okay, let's use that information a little bit. If you were just given this problem, there's no method that we know how to factor that. I don't think there's any method to factor this. Okay, unless you've got some sort of hint. I gave you a hint. I told you to divide by x minus 3. Okay, that showed us that x minus 3 was a factor. But just looking at this, you can't use grouping, you can't use anything to figure this out. So we were able to factor this, though, and it was factors into x minus 3 times our answer, x cubed plus 3x squared minus x minus 1. That's the answer we just got from the problem, right? Okay, look at this big factor right here. Does that factor? Can I factor that anymore? No, I have 4 terms, so I would have to use 4-term grouping. But I've got this pesky 3 in there. And that 3 is going to keep messing things up. No matter how I rearrange it, I'm not going to be able to group it. So this is as factored as that polynomial can get. So let's talk about the roots. What's the only root I know for sure? Well, x minus 3 is a factor. What's the only root I know for sure? 3. Yeah, our only root I know for sure is 3. Okay? How many more do we think there are going to be? There's going to be 3 more, right? 4 total because of this x to the 4th. We know 1 already. And now this tells me that I have 3 more unknown roots. So I don't know what they're going to be. Excuse me. Thank you. But I know at least a little bit. Let's think about the possibilities. My possibilities for roots are either real or imaginary. Now, am I allowed to have 1 imaginary root? No, why not? Yeah, the plus or minus tells me that imaginary roots always, always, always come in pairs. So one option is that I could have 2 imaginary roots, which means I would have how many real roots? Well, I'm just saying from the 3, from this part. Okay? Or what's my only other option? 3 more real. And there's no way to know that unless you graph this, like using your calculator or something, and see how many times it crosses your x-axis. Because a real root is also an x-intercept. Okay? Nothing else we know about that. So I want to introduce you to something called the remainder theorem. The remainder theorem. And here's what the remainder theorem says. It's going to use our remainder to help us figure out some stuff. Okay? This is a specific way to talk about it, then we're going to generalize in just a minute. Okay? Question? If x minus 3 is a factor, then tell me what would also be a root. 3. If this is a factor, if x minus 3 is a factor, then we know that 3 is a root. This f of x that I have written down right here, that's the same as what we did just before. Okay? And I would like for us to now find f of 3. Tell me how I would do that. Yeah, I'm going to plug in 3 for x. Take a second, figure that out. So what'd you get? 0. 0. Where else have we seen that number? It's our remainder. 0 was our remainder. If whatever you're dividing by is a factor, we know that the remainder is going to be 0. The remainder theorem tells us that if we plug in the root from that factor, our answer will always be equal to the remainder. So if 3 is a root, doesn't it make sense that if we would plug it in, we'd get 0? Yeah. So let's generalize that a little bit. Whenever we have f of x, some polynomial, divided by a factor, that will always have a remainder of f of k. Okay? That k is coming from this x minus k. So if we get a remainder of anything else other than 0, then we know it's not a factor. Okay? Similarly, we could plug in that number, that possible root, and if we don't get 0, it's also not a factor. If the remainder is 0, then x minus k is a factor, and k is a root. I'm getting this k by saying, okay, x minus k equals 0. What does x equal? K. That's where I'm getting this k as my root, or the k that I'm plugging in here. And this is just kind of in more math terms. This double arrow means if and only if, meaning each one implies the other. If f of k is equal to 0, then x minus k must be a factor. If x minus k is a factor, then f of k must be equal to 0. Okay? All right, let's try one more. Here's another way that we can use this remainder theorem. We are asked, is x plus 2 a factor of 3x cubed plus 8x squared plus 5x minus 7? So one way we now know how to solve that is using the remainder theorem. The remainder theorem says, plug in that possible root, x equals negative 2, and see if we get 0. That's one way to find out if this is a factor. So 3 times negative 2 cubed plus 8 times negative 2 squared plus 5 times negative 2 minus 7. Go ahead and see what that's going to give me. What'd you get? There it is, a negative. Negative 9. Catherine's like, I'm not going to say it out loud until I know it's right. It is negative 9. Okay, so what does that mean? Negative 9 is my remainder. Is my remainder equal to 0? Nope. So, is negative 2 a root? Negative 2 is not a root, which means x plus 2, is that a factor? No. All right, so let's check this. What time do we read done? At 20? Okay, let's do this quickly then, because I need to show you one thing. So x plus 2, 3x cubed plus 8x squared plus 5x minus 7. I'm going to go through this a little quickly because I got to show you one thing at the very end, okay? X times 3x squared gets me 3x cubed plus 6x squared. Change my signs. Minus, minus. Those cancel. This is 2x squared. I only get to bring down 1 plus 5x. Okay? Now this is going to go in 2x. That's what will get me 2x squared down here. Plus 4x. Change our signs. Cancel, and I get x minus 7. X times 1 will get me x. Then I'm going to have plus 2. I change my signs, and I'm going to get negative 9. Do I have anything left to bring down? No. Where does that negative 9 look familiar to you from? Yeah. We just did. So remember, the remainder theorem says whatever you plug in, hold on, don't close it yet. Whatever you plug in is going to give you your remainder. So my remainder is negative 9. Here's how you write this, okay, to get your final answer. You're going to, since it's a negative, you're going to say minus 9. And then just like in that very first one we did, we put it over whatever we were dividing by, right? So it's going to be over x plus 2. Here's how you write your final answer when you have a remainder. When you have a remainder that's not 0. Now you can close. Yep.